Dear all, welcome. So the topic which we are going to discuss is about specialized medical equipment, and as a part of the course let us start about photometers, and we are going to understand how this photometer instrument is used in biomedical instrumentation. So to begin with, a photometer is an instrument which measures the strength of the electromagnetic radiation, which includes the radiation of ultraviolet, UV radiation, infrared radiation, and as well as visible light rays. And such photometer device actually converts the incident light energy into an electrical current using a photoresistor, photodiodes, or photomultipliers, and this device is used to measure phosphorescence, luminescence, fluorescence, scattering and reflection of light, light absorption, illuminance and irradiance. And based on this basic idea, let us see what this photometer device is and how it will be useful in biomedical instrumentation. So actually this photometer relies upon photometry, which is actually the science of measurement of concentration of any analyte by using its interaction with light at a particular wavelength. To understand this concept, let us go through the basic of Lamberts Law, which states that if we can consider a cuvette with an analytical solution, and the cuvette has a length of small l, and when the light of intensity I0 passes through the cuvette, some of the incident light may get absorbed and some of the light will get transmitted as an output. So according to this law, the intensity of the transmitted light will be different in comparison with the intensity of the incident light. This is because a portion of light may get absorbed by the analyte and a portion of light may get reflected back by the analyte. So based on this concept, the Lambert law relates the absorbance of the analyte with optical path length small l, absorptivity and concentration of the analyte. And the formula is absorbance capital A is equal to the product of epsilon, small l and C, where epsilon is given as absorptivity of the analyte, C is the concentration of the analyte, and L is the optical path length. The Lambert law also states that the transmittance in terms of percentage is given as capital I divided by I0 into 100, where capital I is given as the intensity of the transmitted light and I0 is given as the intensity of the incident light. And based on this Lambert law is what the photometer works. So a photometer in biomedical science is actually used to measure the glucose level and as well as the hemoglobin level in the blood. So we could have seen this kind of photometers in any clinical laboratory, and let us understand the basic physics of how it works based on the Lamberts law. And there are two types of photometric analysis of the instrument. The first one is diffuse reflectance photometry, DRP, and light transmittance photometry, LTP. Let us start the first category, that is diffused reflectance photometry. And we have seen the instrument, and during this technique let us take the blood sample, for which we need to analyze the glucose level and hemoglobin level. This photometry has an inbuilt light source and a photodetector on the other end. Light from the incident light source will be made to fall upon the blood sample, and this blood sample will be absorbing some light source, and a portion of light will be transmitted or reflected at the other end. So the reflected light will be detected by the photodetector, So as we have seen in the last slide, as per the Lamberts law, the intensity of the reflected light and the incident light differs. So that difference is what been analyzed, which gives us the characteristics of the blood sample. As a result, the output characteristics will be displayed as an output. So this kind of measurement of this kind of photometric analysis is based on the reflected light, which means we are understanding the characteristics of the blood using the reflected light from the blood. Hence we call it as diffuse reflectance based photometric analysis. So the second part is light transmittance photometry, LTP. Once again, it includes the same concept, where we have taken the blood sample and we will be mounting it inside the photometer, which has an inbuilt light source and a photodetector. But here in this method, the difference is the light will be made to fall upon the blood sample, and obviously a portion of light will be absorbed by the blood sample and a portion of light may get reflected back, but we are particularly focused on the transmitted light from the blood sample. So that transmitted light will be detected by the photodetector, and as per the Lambert law, the intensity of the transmitted light and the intensity of the incident light differs. That difference will be detected or analyzed, and it will be displayed as an output. So since we use transmitted light to categorize or to analyze the blood sample, this is termed as transmittance based photometric analysis. So based on the output, whatever either it may be reflectance mode or transmittance mode, we will be getting the output from the photometric analysis, that gives us the glucose level and hemoglobin level in the human beings. So this tabular column shows the the glucose level of a normal human being and the patient who is having diabetes. So when the patient is under fasting mode, a normal human being will show the glucose level in the range of 70 to 99 mg by dl, and if the patient is having diabetes, the value shows an increased term between 80 to 130 mg by dl, and the surgeon will be asking us to take a meal, and he will be repeating the experiment after 1 or 2 hours, and in that case a normal human being will show a blood glucose level something less than 140 mg by dl, whereas if a person is having diabetes, he will be having 180 mg by dl, and the surgeon will be doing A1C test, which is nothing but average blood sugar level over the past 3 months, and a normal human being will be having 5.7%, and the person with diabetes will be having a higher value, something around 7%. Using the same photometer, we can able to determine the hemoglobin level as well, and for normal men and adult men, the hemoglobin level in blood should be 13 gram by dl, and for women the hemoglobin level should be 12 gram by dl.